Hello students. So today we will study about rolling on an inclined plane. So this is our topic today. So if a body is rolling on an inclined plane, how actually we can analyze its motion, that is today's topic. So first draw the diagram then. So let's say we have an inclined plane which is making an angle theta with the horizontal. Let this angle be theta. And let's say we have an object. We are considering a circular object which is so it's not circular. So let's say we are considering a circular object which is rolling down through this plane. So as it will roll down, what will happen? Its velocity of its center of mass with which its center of mass is moving, it will increase, as well as its angular velocity omega will also increase with time. Let the radius of this circular body be r. Let this be r. So to actually analyze its motion, we need to first find out what are the forces and torques are working on it. So first, the force, we know that the weight of this object, it will actually act vertically downwards and it will be mg. This plane will also exert a normal reaction which will also pass through the center because it is in the radial direction n. This is normal reaction n, and apart from these two forces there will be also friction acting on it along the plane. So let that be in this direction because it will try to, or it will actually act opposite to the direction of motion. So let this be the force of friction F, and also there will be a force along the plane downward because of its inclination, and let that be, and we know that this force is given as what? Mg cos theta, mg sin theta, where theta is the angle of inclination. So this is, these are the forces acting on this body. Now to write the equation of motion, first of all, for its linear motion we can write, or before that, that we must actually have the condition here that we are considering here pure rolling. Yes, that is important. First, pure rolling. What is pure rolling? Pure rolling means that there is no sliding, that is actually the point of contact is at rest with respect to the plane. So we know that for pure rolling we have these relations. What is the relation? For pure rolling, the linear velocity v is equal to omega times, that is the angular velocity, multiplied by the radius of the object. Also its linear acceleration a is equal to alpha r, where alpha is the angular acceleration, because when the body will actually come down along this plane, its linear velocity will increase as well as its angular velocity will also increase. So these two relations must be satisfied here because it is pure rolling. In case of pure rolling, these two relations always satisfy. Now coming to the equation of motion, so for the equation of motion, what we can write along the plane, equation of motion along the plane. So equation of motion along the plane, as you can see that along the plane there are two forces acting, F and mg sine theta. So if the object is actually coming down with acceleration a, so along the plane the equation will be mg sine theta writing in the red color. So it will be mg sine theta minus f should be equal to the force acting on the body, that is ma. Okay, so this is the equation for the linear motion. Now here, as you can see that as the object is rolling there must be a torque acting on it, and actually what are the forces that can produce the torque? You can see from here that the force mg and the force normal reaction n, both are actually passing through the mm, axis of, or it is actually the line of actions of these two forces are passing through the axis of rotation, so they will not produce any torque. The torque will be only produced by the force of friction F, as its line of action is not passing through the axis of rotation. So for the torque equation we can write here the torque tau is equal to F R, and we also know that torque is actually the moment of inertia multiplied by the angular acceleration. So this is the equation for rotational motion here, because the other forces are not producing the torque, only the force of friction is actually producing the torque, as you can see. So from here, if we want to find out A, so first we are replacing alpha with A from this relation. So we can write from here Fr is equal to I A by R. That can be written. So from here, if we actually replace or find out the value of F, the force of friction will come I A by R square. Now if we put this value of friction in this equation of motion, the linear equation of motion, we will get mg sine theta minus I A by R square is equal to ma. So from here, if we take A common and take the terms on the same side, so A m plus I by R square is equal to, it will come as mg sine theta. Dividing both sides by m, we will get a as g sine theta by 1 plus I by mr square. This is the acceleration with which the body will come down. So this is very important. The linear acceleration, the value of its the value of the linear acceleration of the body is what? G sine theta by I by mr square. So for any body, circular body, if we know the its moment of inertia, we will be able to find out the linear acceleration with which it is coming down. Okay, so this is the linear acceleration. Now what about the velocity of the object or the body when it will reach the bottom part, that is here? When it will reach here, what will be the velocity? Let that velocity be v final. So I am writing this velocity be vf. So to find out vf, what we need to do, we just need to apply the equation v square is equal to u square plus 2as. And if we consider that the body is actually starting from rest, u will be 0 and we will get v square is equal to 2. A we have just found out, it is 2g sine theta by 1 plus I by mr square, and its displacement along the plane, as you can see, if this height is h, actually its displacement along the plane in terms of this height h and theta will be h by sine theta. So we can write this as multiplied by h by sine theta. So phi will come, sine theta will cancel, it will come root over of 2gh by 1 plus I by mr square. So this is another important relation, that is what should be the velocity of the body when it will reach the bottom. It will be this. So this is actually the main theoretical part from here. What is the acceleration and what is the velocity? This is the acceleration and this is the velocity. So let's solve some problem from this theory. So here there is a problem which is saying that consider a situation in which a ring, a solid cylinder and a solid sphere roll down on the same inclined plane without slipping. Assume that they start rolling from rest and having identical diameter. The correct statement for this situation is the sphere has the greatest and the ring has the least velocity of the center of mass at the bottom of the inclined plane. The ring has the greatest and the cylinder has the least velocity of the center of mass at the bottom of the inclined plane. All of them will have same velocity. The cylinder has the greatest and the sphere has the least velocity of the center of mass at the bottom of the inclined plane. So at the bottom of the inclined plane we have just derived the velocity is root over of 2gh by 1 plus I by mr square. So you see that the velocity will be maximum for that object for which I is minimum, because I is at the denominator here. So the object having the maximum or the greatest I will have the least velocity. So for this ring, solid cylinder and solid sphere, for ring we know I ring is actually given by mr square. I solid cylinder is given as half mr square, and I solid sphere is given as 2/5 mr square. So you can see what is having the maximum moment of inertia, ring. What is having the least, the sphere. You can see from here. So I ring is the maximum, I sphere is the least. So the first statement, the sphere has the greatest and the ring has the least velocity of the center of mass at the bottom of the inclined plane, that is correct. So the answer will be 1. This is correct. So answer will be 1, because the ring is having the maximum moment of inertia and the solid sphere is having the least moment of inertia. So it will be reverse for the velocity at the bottom. So answer will be 1. Okay. So this is 1. Let's do another one. So here it is said a sphere of mass 2 kg radius and 0.5 meter is rolling with an initial speed of 1 meter per second, goes up an inclined plane which makes an angle of 30 degree with the horizontal plane without slipping. So without slipping means again we are having pure rolling. How long will the sphere take to return to the starting point? Now for the, so here this is the problem. So as we know, we have already just discussed that the acceleration a for a sphere will be what? G sine theta by 1 plus I for a solid sphere is 2/5 mr square by mr square. So for a solid sphere, A will come as mr square will cancel. It will come as 5g sine theta by 7. This will be the acceleration of the sphere along the plane. Now actually whether the sphere will come down or go up along the plane, this this a will remain same. That we have to remember, because it can be actually shown that when a sphere is going upwards, or rather you can say by the symmetry actually of the situation, when something will go up, how much time it will take will actually take the same time when it will come down to the same place. So here we need to remember this, that whether the body is going up or coming down, a is same for both the cases. So a is this. Now if we actually put the value here of g as 10 for simplicity, we will get 5 multiplied by 10 multiplied by half by 7. So that will actually give us 25 by 7. A is equal to 25 by 7 meter per second square. That we will get. Now use the kinematics relation, S is equal to ut minus half at square. S is equal to ut minus half at square, because we need to find out the time here. So here as it is coming to the initial place, S is 0, u is given as 1 meter per second. So t minus half multiplied by 25 by 7, a we have already calculated, multiplied by t square. So from here it can be written as 0 is equal to t 1 minus 25 by 14 t. So as t is not equal to 0, we must have 1 minus 25 by 14 t is equal to 0, or t is equal to 14 by 25 seconds. So if we do this, it will come around 0.56 seconds. Now, what are the options? Options are this: 0.8, 0.6, 0.5 to 0.57. So 0.57 is closest to 0.56. This will be the answer. Actually, the difference in answer has come due to the approximation that we have taken G as 10. Okay, if we would have taken G, if we had taken G as 9.8 meter per second square, then the answer would have been close to or closer to 0.57 second, but it is also close. So the answer will be 4. So here the answer is 4. So that is how we actually solve the problems or the situations for rolling on an inclined plane. Thank you.